Alrighty, so we're back at it. We're going to talk about the next thing we're going to do with polynomials, right, which is multiplying them, right? So we've talked about naming them, we've talked about adding and subtracting them. Now we're going to get on to actually like doing more with them, right? So we're going to multiply. So first off, what we're going to start off with is we're just going to multiply two monomials, right? Two just chunky pieces of stuff. So the way that we're going to multiply these is we're going to multiply the pieces that seem like they multiply well, multiply those, right? So 9 and 8 are just numbers, right? We know how to multiply 9 times 8. That's going to give us 72. All right. After that, what I'm going to do is I'm going to take a look at the x's, right? X's seem like they should go with other x's. And this isn't really something that you guys may have run into before. So let's take a quick trip over to the side here, right? X to the fourth times x to the third. All right, so we've got x to the fourth times x to the third. All right, we got to figure out what those things actually are, right? Like, what is x to the fourth? So x to the fourth is actually what you get when you multiply four x's together, right? So it's x times x times x times x, right? That's what x to the fourth is, right? By the same measure, right? X to the third is x times x times x, right? There's three of them all together, right? So the x one is telling you how many of that same thing you have multiplying itself, right? It's how many times you're multiplying it by itself. So if I kind of, I'm going to kind of teleport this plus sign in the middle straight down into the center right here, right? If I go ahead and I do that, what I'm going to find is that I have all of these x's multiplying together, right? If I count them all up, right, I have 4 on the left, 3 on the right, altogether that's 7 x's. I'm going to call that x to the 7th. Right, that's how we're going to tackle all these multiplying ones here, is we're basically just going to be adding the exponents, right? But remember that this is really what's going on this screen right here, right? We have 4 x's times another 3 x's, so there's 7 x's multiplying each other all together. Right, so, like we just said, right, that's going to come out as x to the 7th for this piece here. We catch up on the color coding a little bit. Cool. After that, we're going to go ahead and we're going to do the y's. And so, as we kind of talked about in the naming video and with some other stuff, right, this y that's over on the right side, right, the second y, does have a power of 1 there, right? That's going to be important for what we're doing here. What that's saying is that I have 5 y's in the left part times another 1 y, right? So altogether I'm going to have 6 y's, or y to the 6th, when we do that. Right? So again, we're just choosing the pieces that seem like they go together, we're matching them up and multiplying those. Let's try another one out. Same kind of deal, right? I'm going to take the pieces that look like they go together, right? 5 and 7 would multiply just fine. 5 times 7 is going to give me 35. Right? After that, we've got an x squared, we've got an x to the 5th. Right? Take a quick second, think about what that should come out to be if you have 2 x's and you're multiplying by 5 more. What that's going to give us is that's going to give us x to the 7th. Bingo, bango, bongo, we're almost done. We got y to the 4th times another y. Right, so just like up top, right, this y has a little 1 on there. Right, so again, take a second, think about what that should come out to be. What we're going to get is that it comes out to be y to the 5th, right? I had 4 all multiplying each other, and then I now added, or I multiplied by a 5th one, so we have y to the 5th. Right, so hopefully this part doesn't seem so bad so far. Right? As is traditional with math, it does get a little bit worse, right? But it's not gonna get too much worse here, right? So basically what we're going to be doing is like some big fancy distribution. Right? So you remember the distributive property. You've got something on the outside of some parentheses, and then what we're going to do is we're just going to kind of multiply it in there and all that. Same idea. Right? It's just that the pieces that we're multiplying are going to look a little nastier than we're used to. Right? So let's take this one piece at a time. I'm going to do 5x squared. I'm going to distribute it into that negative 4x squared. All right, so when I go ahead and do that, I'm doing the same thing that we just did up top. Right? The 5 and the negative 4 will multiply. That'll give me negative 20 for those. And then the x's multiply, right? I had 2 on the outside times another 2 on the inside. So that's x to the 4th total. All right? Same kind of deal. We're just going to keep on going. Right now I'm going out to that positive 2x. Right? Don't forget that when we're doing stuff with parentheses, we're grabbing the signs that come in front of these things. Right, so that was a negative 4. This is a positive 2, and then when we get to that piece in orange, that's going to be a negative 7. Right, so be careful on that. When we're doing this blue one, though, right, the 5 and the positive 2 multiply to give me positive 10, or plus 10. We had 2 x's on the outside times another one on the inside. So it's going to give me 3 of those overall multiplying. And then we're moving on to the orange piece at the end. Right, so we have 5 times negative 7 is negative 35. And then we've got that x squared, which in this case doesn't have anything to multiply with, right? But that's okay, right? We're still multiplying with it. We're going to bring it right along. Right? After that, we're done. Right? That's all we really needed to do, is just kind of doing that multiplication out. Yeah, let's take a look at another one. So this one down here, right, we have negative 3x squared. First thing I'm going to do is I'm going to distribute it into just that first term there, 7x squared. Right, so the negative 3 times the 7 is going to give us negative 21. Same as before, right? On that last one, we had x squared on the outside times x squared on the inside. Same deal here, right? That's going to give us x to the 4th. Piece in the middle here, right, is a negative x. Right? Again, we were kind of talking about how you got to grab the sign that comes in front of it as well. So you might be saying to yourself, like, there's nothing for the negative 3 to multiply with. Oh, let me tell you what. There's an invisible 1 in front of that x, right? If you have an x, you have one x, right? So what we're going to do is we're going to have that negative 3 times that negative 1 is going to give us positive 3 there. All right, the x's should hopefully not be too much of a problem, right? We had 2 on the outside, multiply by another one on the inside, gives me a third x there. Last but not least, we're going to distribute out to that plus 4. So negative 3 times positive 4 is going to give us negative 12. Again, just like the last one, that x squared kind of comes along. It doesn't have anybody to go with, but that's all right. And again, we're done. That's it. Sometimes they do get to be a little bit longer of a problem, right? So something like this one, right? We've got this monomial on the outside, right? This is one term, times this polynomial with 4 terms on the inside. So I'm going to end up having 4 different chunks to do. Right? If it helps you, right, you could do sort of like I'm doing. Even if it's with one color, that's all right. Right? But if you're doing these out on paper, you know, make sure that you're grabbing the little sign that comes in front of it as well. It's not going to hurt. All right, so first one there, we have negative 6 times positive 3 is negative 18. We had x to the 3rd times another x to the 4th. So altogether, I'm going to have 7 of those. That part's all done. Piece in the blue, we have negative 6 times negative 2 is positive 12. And then if we add x to the 3rd times another x to the 3rd, that'll give me x to the 6th. Right? Because again, it's our little shortcut way is that we're just adding the exponents together. When we're doing this orange piece, right, remember that there is a 1 in front of that x. There's also a 1 on top of the x, right? It's x to the 1st. And so when I'm doing that one out, I've got negative 6 times negative 1 is positive 6. And we're going up on those x's by 1. So we have x to the 4th. And last but not least, way down at the end of there, zoom in a bit, we have negative 6 times positive 9 is negative 54. And then we'll have x to the 3rd that kind of comes along for the ride. And so hopefully this doesn't seem so bad so far, right? We're just doing fancy distribution, right? It's the exact same thing as what we did up top here, right? Just grabbing the pieces that seem like they go together, except we're doing it like several times, right? That's the only real difference here. And sometimes you're going to run into ones like these. So these ones can be a little bit tricky if you're not careful. All right, so first things first, we've got this 2x in front of the first set of parentheses. What I'm going to do is I'm going to distribute it into just that set of parentheses that it's next to. All right. When we get over to this negative 5, right, again, I'm grabbing the sign in front of it. I'll be taking that negative 5 and distributing that into those parentheses there. Right? You don't want to take that 2x and go hog wild and multiply it to absolutely everything. Right? It's only multiplying that first set of parentheses. All right, so when we're taking a look at that first set, we've got 2x times negative 4x squared, so we'll get negative 8x to the 3rd. 2x times 5x is going to give us plus 10x squared. Right? So again, I just went ahead and I multiplied the numbers by the numbers, the x's by the x's for each one of those. On the second one, I'm making sure to take negative 5 and multiply it in there. So negative 5 times positive 2 is negative 10. I have an x squared on the inside that needs to come along. Right? And then last but not least, we got negative 5 times positive 20, which is negative 100 there. Cool. So on the last couple, this is where we would be done. Right? But unfortunately, what we got here is we actually have some like terms that we can combine. Right, so thinking back to the adding and subtracting video, right, if you need to pause this and go back and take a look at that, that's not a bad idea. I've got these like terms in the middle, right? I have 10x squareds, and then I'm later on saying minus 10x squareds. Right, so the negative 8x to the third is going to stay the same, right? That didn't have any like terms. This minus 100 at the end is going to stay the same. But the question is like, all right, what do we get when we do that piece in the middle there? Right, so when we do that, oops, it erased to 0. We do that piece in the middle, right, we're going to take 10x squareds, and we're going to take away 10x squareds, right? So I don't have any x squareds, right? So, what some people like to do is they like to put it in as plus 0x squareds, right? There aren't any there, right? But it's perfectly acceptable to just say, oh, you know what? If I don't have any, why bother writing them, right? Why don't I just leave it like this, right? This is most often how you're going to see your answer to these types of questions, right? It's not going to leave in the 0x squareds or the 0y to the fourths or whatever it is that has a 0, because you literally don't have any of them, right? So why bother writing them? And so I would suggest, if it helps to write in the little 0x squared in the middle, that's fine, right? Even if you left your answer like that, it's not technically wrong, but the one that I have boxed in there is more often what you're going to want to have that as. All right. Let's try another one of these. So if at any point on any of these, right, I should mention, if you want to pause it, try it on your own on a piece of paper, and then come back and watch me do it out, that's not a bad idea. It's actually probably an awesome idea. All right, so if you wanted to pause this one here and try number 7 on your own, and then unpause it, like put me back on, as much as I know that that's probably not fun, right, and then check and see how you did based on what I'm doing, it's not a bad idea. Alright, so what I'm going to do here, right, is I'm going to kind of notice that I've got that 3 that's going into this first set of parentheses here. Right? And then I want to notice that I also have this negative 1x that's got to go into the second set there. And so you might notice that we've got a whole ton of stuff that's going to be going on here, right? We're going to end up with 6 different times, right? One for each of those arrows that we got to do this. But luckily, there's not too much going on with each one. All right, we've got 3 times 5x squared. Right, so the 3 and the 5 goes 15, the x squared comes along. For the second arrow, the 3 times the 2 gives us 6, and that x comes along. And then we do 3 times negative 4 is negative 12. Cool, first parentheses all set. On the second one, we're going to have negative 7 x to the third, right, just going negative 1 times 7, and then x times x squared. We're going to have negative 2 x squared for the second arrow there. We're going to have plus 3x at the end. And so just like before, we have some like terms that we can smush together here. Right, the tricky part sometimes is figuring out which ones are which. So I've got this x squared out in the front. I have minus 2x squared a little bit later on. Right, I've got these regular old x's and these regular old x's. And then I've also got, oops, I already used that one. I've also got this minus 12. And I also have this minus 7x to the third that don't have anybody to combine with. Right? But the important part is we don't want to forget about them. Right? So negative 7x to the third, it's got the biggest power. We could write that one out in front. Right? I know that I don't need to do anything with it, right? So that's pretty nice. The next highest power, right, if we're trying to write them in standard form, if you need a little bit of a refresher on standard form, you're going to want to check out the first video on the naming of these different polynomials. Right. The next highest power are these ones with the x squareds on them, right? So the ones that are underlined in purple. If I had 15 of them, I'm taking away 2, I still have positive 13 x squareds. Right, cool. After that, I'm taking a look and I'm seeing that the ones in green are just regular x's. I had 6 x's in the front, and I added 3 more on, so I have 9x from there. And last but not least, we don't want to forget about that minus 12. It comes last because it doesn't really have any x's, right? It would have the least number of x's, right? So that's all we got to do, right? I'm not going to say that was like quick and easy, but it wasn't, so hopefully super duper bad, right? It's a little bit tedious to kind of go through these. Hopefully they don't seem that hard. They're just long. Right. Let's try another one out. And this one, again, what I might suggest is, especially if you didn't try number 7, pause the video, try out this number 8 one, see how you do. Alright, so I'm going to go ahead and go through this one. I'm going to take this 15x, go into both of those. So I have 15 times 10 is a solid 150. The x multiplies with the other x's, right? So I had one on the outside times another 5 on the inside, which gives me x to the 6th. That y to the 3rd still comes along. Right? We didn't have any y's to multiply by, but that's okay. Right, then what we're going to do is we're going to do 15 times 5, right? So that's going to be 75. X times x gives me x squared, and then that y squared comes along as well. Right, after that, I'm moving on to this second set of parentheses. I'm going to take that negative 2y and multiply that in there. So we'll have negative 2 x squared y squared. And we had to do a lot of just like dragging things along with that one, right? The only things that actually multiplied were the y's. Right, but we don't want to forget the negative 2. We don't want to forget the x squared. Right? We need all of that together. Last arrow there, negative 2 times positive 4 is going to be negative 8. And then we'll have 3y, so y to the 3rd there. Right. As I'm looking at this big awful mess, what I'm noticing is that we do actually have some like terms right here in the middle. Right? We have x squared, y squared on both of those. Right, the one in the front and the one in the back certainly do not go together. Right, so we're just going to bring those right on down. We got 150 x to the 6th, y to the 3rd. This piece in the middle, right? I had 75 x squared, y squareds, and then I'm taking 2 of them away. So I'm going to have 73 x squared, y squareds. And then last but not least, rounding things off, I have minus 8y to the 3rd. Right, cool. So when we're through with that one, right, that's it. Right, I don't have anything else left to do. So what we're going to do down here, right, is that we've got some expressions, and what it wants us to do is it wants us to go through them and say, like, all right, I'm taking a look at it. Does it look like this person did it the right way, or did they make some sort of a mistake along the way? Right. So again, not a bad idea if you wanted to pause these, take a quick look, try them on your own, see if you can tell which ones they did right. That's not a bad idea. Right, as I'm looking at this first one here, right, I'm saying like, all right, I have 2x on the outside with the original expression, and then we've got just one thing on the inside. Huh. But then as I take a look at the answer that they got over there, whoops, where'd it go? Oh boy. There we go. Doesn't quite look correct, right? Somehow they just like added in these plus signs. Right? Whereas our original expression didn't have any plus signs. Right? So what it looks like they tried to do is they just like added addition. Added pluses, question mark? That's awfully strange, so that's not going to be right. Oh, let's see if we can get it better. There we go. No way. As I'm taking a look at the second one there, and I've got that 3x squared, or negative 3x squared kind of distributing in there. Looks like they changed their sign correctly on this first part, right? The x, like the variables all look fine. We have 3 times 7 gave us negative 21 in the middle. Again, the variables look alright. And then they remembered to change that to plus 15 towards the end. Seems like this one is a winner, right? Pretty correct. And we're taking a look at this next one here, right? 7x to the 3rd y times 4xy to the 4th. Right? These are just like the ones that we started off talking about, right? I've got 7 times 4 is 28. X to the 3rd times another x is x to the 4th. And y times y to the 4th is y to the 5th. This one also seems like it's correct. Right? Things are looking up. Alright, cool. So then on this one here, we've got 7xy. Alright, so if I'm going ahead and doing that first step, 7 times 2 is 14. We get x to the 4th and y squared. Looking good so far. And then things kind of fall apart. Yuck. Oh my god, it was looking so good so far. So what I'm noticing is that they just took these exact pieces and just brought them over to their answer. Right? They didn't actually do the distribution. Right? It looks like they just went like Oh, cool. Wow, that was such a long day. I'm so glad that I learned how to multiply these. I am done. I am spent. Let's just write down the rest of it. They just forgot to do all the rest of the multiplying. So that's a no, right? They didn't distribute. They just did the first part. And then this last piece here, right? I know that people are going to see fractions and they're going to be like, oh my god, Mr. Pog, how can you expect me to do anything with fractions? Eek. Right? Fractions aren't that bad, right? You're taking a fourth of something, right? So imagine if you had it all in a big pizza pan, and you take a fourth of it, right? So 1/4 times 8 is going to give me 2, right? 1/4 of 8 is 2. Right? The variables are looking good on that one, right? So things look good so far. If I had 2 and I wanted to take 1/4 of that, that would be a half. And the variables look, again, pretty okay on that second piece. 1/4 of 20 is 5, right? And they remembered to leave it as -5. The variables look good, right? This one looks fine. So, what I would suggest is after going through this, right, if you need to go back and take a look at anything, if you want to then like go back, try one of the earlier examples, pause the video, and then take a look back at how we did it again. That's not a bad idea. I would check on Google Classroom as well, especially check out those plans, see what's coming next and what you should be doing from here, and I am out.